Hello learners, welcome to NIOS. Today we will discuss the topic humidity and precipitation. Our objectives are to distinguish between absolute and relative humidity and to identify the factors affecting the rate of evaporation, to analyze the various forms of condensation, to distinguish among the types of precipitation, that is rainfall, to study the salient features and factors affecting distribution of precipitation. Let's begin with water vapor. Water vapor is a highly variable component of the atmosphere. Its proportion varies from 0 to 4% by volume of the atmosphere. Water can exist in the air in all the three states of matter, that is solid, ice crystals, liquid, droplets of water, and gaseous, that is water vapor. Most commonly, water exists in air as tasteless, colorless, transparent gas known as water vapor. The presence of water in the atmosphere has made life possible on the earth. Let's examine its significance of life on earth. Look at this picture which depicts the water cycle, how water evaporates from the earth, goes back to the atmosphere, and condensation happens which leads to precipitation. Water vapor in atmosphere absorbs a significant portion of both incoming solar energy and outgoing earth radiation. It prevents great losses of heat from the earth's surface and helps to maintain suitable temperatures on the earth. The amount of water vapor present in the air affects the rate of evaporation. The amount of water vapor present in a volume of air decides the quality of latent heat or energy stored in it for producing atmospheric changes. And the amount of water vapor that is present in the air of a place or in a region indicates the potential capacity of that air for precipitation. The amount of water vapor present in the air also affects standing crops favorably. Air poor in water vapor content makes our body skin dry and rough. It is because of this fact that we use moisturizers, lotions to protect our faces from dry air of cold winters or hot summers. Now let's move on to humidity. The heat energy radiated from the sun changes water into water vapor. This invisible water vapor present in gaseous form in the atmosphere at any time and place is termed as humidity. In other words, we can say that the term humidity refers to the amount of water vapor present in a given air. It indicates the degree of dampness or wetness of the air. Humidity of the air is mainly expressed in the following two ways: absolute humidity and relative humidity. Look at this diagram which is showing maximum absolute humidity for a wide range of temperature. Absolute humidity is a ratio of mass of water vapor actually in the air to a unit mass of air including the water vapor. It is expressed in gram per cubic meter of air. For example, if the absolute humidity of air is 10 grams, it means that 1 cubic meter of that air holds 10 grams of moisture in the form of water vapor. Absolute humidity is variable and changes from place to place and the change in time. The ability of air to hold water vapor depends entirely on its temperature. The capacity of holding water vapor of an air increases with the increase in its temperature. For example, at 10 degrees C, 1 cubic meter of an air can hold 11.4 grams of water vapor. Now let's come to relative humidity, which is the most important and reliable measure of atmospheric moisture. It is the ratio of amount of water vapor actually in a volume occupied by air to the amount the space could contain at saturation. Air can hold a definite maximum quantity of water vapor at a given temperature. When this situation is attained, we say the air is fully saturated. The temperature at which a given sample of air becomes fully saturated is called the dew point or saturation point. The relative humidity of air at saturation point is 100%. Since the concept of relative humidity is very important in understanding this lesson, let us look at the figure. Air can hold 22.2 grams of water vapor at 21 degree temperature. If this air is holding 11.1 grams of water vapor at the same temperature, that is 21 degree Celsius. The relative humidity of the air will be 11.1 multiplied by 22.2 into 100 or 50%. And if the same air is actually holding 22.2 grams of water vapor at 21 degrees Celsius, the relative humidity of air will be 22.2 by 22.2 into 100 or 100%. The air becomes saturated when its relative humidity is cent%. If the relative humidity of air is less than 100%, the air is said to be unsaturated. Now let's come on to evaporation, which is the process of which water changes from its liquid state to gaseous form. This process takes place at all places, at all times, at all temperatures except at dew point or when the air is saturated. The rate of evaporation is affected by several factors, which are accessibility of water bodies. That means the rate of evaporation is higher over the oceans than on the continents. Secondly, temperature. As the hot air holds more moisture than cold air, so when the temperature of air is high, it is capable of holding more moisture in its body than at a low temperature. It is because of this that the rate of evaporation is more in summers than in winters. That is why wet clothes dry faster in summers than in winters. Look at this very interesting picture, which is showing us the process of condensation, precipitation, evaporation, which further leads to precipitation. Air moisture. If the relative humidity of a sample of air is high, it is capable of holding less moisture, and if the relative humidity is less, it can take more moisture. Hence, the rate of evaporation will be high. Aridity or dryness of the air also increases the rate of evaporation. During rainy days, wet clothes take more time to dry owing to the high percentage of moisture content in the air than on dry days. Similarly, another factor is wind. Wind also affects the rate of evaporation. If there is no wind, the air which overlies a water surface will get saturated through evaporation. This evaporation will cease once saturation point is reached. However, if there is wind, it will blow that saturated or nearly saturated air from the evaporating surface and replace it with air of lower humidity. This allows evaporation to continue as long as the wind keeps blowing saturated air away and bringing in the drier air. Another factor is cloud cover. The cloud cover prevents solar radiation and thus influences the air temperatures at a place. This way, it indirectly controls the process of evaporation. The heat energy used for changing the state of water or a body from liquid to gaseous state or from solid, that is ice, to liquid, that is water state, without changing its temperature is called latent heat. The latent heat consumed in changing water vapor into gaseous form is released when water vapor changes into water or ice. The release of latent heat in the air is an important source of energy for causing changes in weather. A special case of evaporation is transpiration, which entails a loss of water from leaf and stem tissues of growing vegetation. The combined losses of moisture by evaporation and transpiration form a given areas are termed as evapotranspiration. Condensation is the process by which atmospheric water vapor changes into water or ice crystals. It is just reverse of the process of evaporation. When the temperature of saturated air falls below the dew point, the air cannot hold the amount of humidity which it was holding earlier at a higher temperature. This extra amount of humidity changes into water droplets or crystals of ice depending upon the temperature at which condensation takes place. What is the process of condensation? The temperature of the air falls in the following two ways. Firstly, cooling occurs around very small particles of freely floating air when it comes in contact with some colder object. Secondly, loss in air temperature takes place on a massive scale due to rising of air to higher altitudes. The condensation takes place around the smoke, salt and dust particles which attract water vapor to condense around them. They are called hygroscopic nuclei. When the relative humidity of air is high, a slight cooling is required to bring the temperature down below the dew point. But when the relative humidity is low and the temperature of the air is high, a lot of cooling of the air will be necessary to bring the temperature down below the dew point. This condensation is directly related to the relative humidity and the rate of cooling. Now, what are the forms of condensation? Condensation takes place in two situations. Firstly, when dew point is below freezing point or below 0 degrees Celsius. And secondly, when it is above freezing point. In this way, the forms of condensation may be classified into two groups. First, being frost, snow and some clouds are formed when dew point is below the freezing point. Secondly, dew, mist, fog, smog and some clouds are formed when dew point is above the freezing point. The forms of condensation may be classified on the basis of place where it is occurring. For example, on the ground or natural objects such as grass blades and leaves of the plants or trees, in the air close to the earth's surface or at some height in the troposphere. Condensation in dew form occurs when there is clear sky, little or no wind, high relative humidity and cold long nights. These conditions lead to greater terrestrial radiation and the solid objects become cold enough to bring the temperature of air down below the dew point. In this process, the extra moisture of air gets deposited on these objects. Dew is formed when dew point is above freezing point. Dew formation can be seen if the water is poured into a glass from the bottle kept in a fridge. The outer cold surface of the glass brings the temperature of the air in contact with the surface down below dew point and extra moisture gets deposited on the outer wall of the glass. Look at this picture which shows the dew drops on a leaf. This is when the atmospheric moisture is condensed and deposited in the form of water droplets on cooler surface of solid objects such as grass blades, leaves of plants, trees and stones. Frost. When the dew point is below freezing point under above mentioned conditions, the condensation of extra moisture takes place in the form of very minute particles of ice crystals. It is called frost. In this process, the air moisture condenses directly in the form of tiny crystal of ice. This form of condensation is disastrous for standing crops such as potato, peas, pulses, grams, etc. It also creates problem for road transport system. Mist and fog. When condensation takes place in the air near the earth's surface in the form of tiny droplets of water hanging and floating in air, it is called mist. In mist, the visibility is more than 1 kilometer and less than 2 kilometers. But when the visibility is reduced to less than 1 kilometer, it is called fog. Ideal conditions for the formation of mist and fog are clear sky, calm and cold winter nights. Now, smog. Smog is a fog that has been polluted and discolored by smoke, dust, carbon monoxide, sulfur dioxide, and other fumes. Smog frequently occurs in large cities and industrial centers. It causes respiratory illnesses. Look at this picture, which is showing a misty morning. Frost, smog, and fog. These pictures are depicting all the three condensation forms. Now let's come on to clouds. Clouds are visible aggregates of water droplets, ice particles, or a mixture of both along with varying amounts of dust particles. A typical cloud contains billions of droplets having diameters on the order 60.01 to 0.02 millimeters. Clouds are generally classified on the basis of their general form or appearance and the altitude and may be grouped as number 1, low clouds. The base level of low clouds varies from very near the ground to about 2000 meters. The basic type of this family is a stratus, a low uniform layer resembling fog but not resting on the ground. Stratocumulus clouds form a low grey layer composed of globular masses or rolls which are usually arranged in groups, lines or waves. Look at the picture of the clouds beautifully scattered in the sky. Then we come to medium clouds. These clouds are formed at altitudes between 2000 to 6000 meters. This group of clouds includes altocumulus and altostratus. High clouds, these clouds are formed above the altitude of 6000 meters and include cirrus, cirrostratus and cirrocumulus. These are the three types of clouds depicted in a diagram of atmospheric layers. Clouds with vertical development fall into two principal categories, cumulus and cumulonimbus. Cumulus clouds are dense, dome-shaped and have flat bases. They may grow to become cumulonimbus. The extent of vertical development depending upon the force of vertical currents below the clouds as well as upon the amount of latent heat of condensation liberated in the clouds. At cumulus, clouds are dense, dome-shaped and have flat bases. A cumulonimbus cloud may cover the whole sky and have the appearance of nimbostratus. The word nimbus or prefix nimbo applies to a cloud from which rain is falling. It derives from the Latin for violent rain. Now let's move on to precipitation and its various forms. Precipitation is defined as water in liquid or solid forms falling to the earth. It happens when continuous condensation in the body of air helps the water droplets or ice crystals to grow in size and weight that the air cannot hold them, and as a result, these start falling onto the ground under the force of gravity. The precipitation falls on the earth in various forms of droplets of water, ice flakes, solid ice balls, or hail, at times droplets of water and hail together. The forms of precipitation are drizzle and rainfall. Drizzle is a fairly uniform precipitation composed exclusively of fine drops of water with diameter less than 0.5 mm. Only when droplets of this size are widely spaced, they are called rain. Look at this picture which is depicting the three types of rain. The first one is showing hailstones, then the rain, and the third picture is showing snowfall. Snowfall is when condensation takes place below the freezing point. The water vapor changes into tiny ice crystals. These tiny ice crystals grow in size and form ice flakes, which become big and heavy and start falling on the ground. This form of precipitation is called snowfall. Snowfall is very common in western Himalayas and the mid and high latitude regions in the winter. Now, what is sleet? Sleet is frozen rain formed when rain before falling on the earth passes through a cold layer of air and freezes. The result is the creation of solid particles of clear ice It is usually a combination of small ice balls and rime. Hail. Hail is the precipitation of small balls or pieces of ice with diameter ranging from 5 to 50 millimeters, falling either separately or agglomerated into irregular lumps. Hailstones are comprised of a series of alternating layers of transparent and translucent ice. Now, what are the types of rainfall? When a mass of moist air ascends to high altitudes, it cools down to lower temperatures. In doing so, it attains dew point, which leads to condensation and precipitation. Thus, the cooling of air occurs mainly when it rises. There are three important ways in which a mass of air can be forced to rise and produce its own characteristic precipitation or rainfall. The first type is convectional rainfall. Excessive heating of the Earth's surface in tropical region results in the vertical air currents. These currents lift the warm, moist air to higher strata of atmosphere. When the temperature of such a humid air starts falling below dew point continuously, clouds are formed. These clouds cause heavy rainfall, which is associated with lightning and thunder. This type of rainfall is called convectional rainfall. It is very common in equatorial region. The second is orographic or relief rainfall, which is formed where air rises and cools because of a topographic barrier. When their temperature falls below dew point, clouds are formed. These clouds are widespread rain on the windward slopes of the mountain range. This type of rain is called orographic rainfall. However, when these winds cross over the mountain range and descend along the leeward slope, they get warm and cause little rain. Region lying on the leeward side of the mountain receiving little rain is called rain shadow area. A famous example of orographic rainfall is Cherrapunji on the southern margin of Khasi Hills in Meghalaya, India. Third type is the convergence or cyclonic rainfall. Convergence rainfall is produced where air currents converge and rise. In tropical regions, where opposing air currents have comparable temperatures, the lifting is more or less vertical and is usually accompanied by convection. Convection activity frequently occurs along fronts where the temperature of air masses are quite different. Mixing of air along the front also probably contributes to condensation and therefore the frontal rainfall. When two large air masses of different densities and temperatures meet, the warmer moist air mass is lifted above the colder one. When this happens, the rising warm air mass condenses to form clouds, which causes extensive downpour. This rainfall is associated with thunder and lightning. This type of rainfall is also called frontal rainfall. This type of rainfall is associated with both warm and cold fronts. Look at this picture, which is depicting all four kinds of rainfalls. Convectional rainfall, orographic rainfall, then the cyclonic rainfall is of two types, one associated with warm current and the other with the cold front. Distribution of precipitation. The spatial distribution of precipitation is not uniform all over the world. The average annual precipitation of the world as a whole is about 97.5 centimeters. But the land receives lesser amount of rainfall than the oceans. The annual precipitation shows marked difference on the land. Different places of Earth's surface receive different amount of annual precipitation and that too in different seasons. The main features of distribution of precipitation can be explained with the help of global pressure and wind belts, distribution of land and water bodies, and the nature of relief features. Before arriving at any conclusion regarding the causes for regional and seasonal variation, let's first see regional and seasonal distribution patterns of precipitation. What are the regional variations? Regions of heavy precipitation are the regions which receive more than 200 centimeters of annual precipitation, and they are in this category. These regions include equatorial coastal areas of tropical zone and the west coastal regions of temperate zone. Regions of moderate precipitation. These regions which receive 100 to 200 centimeters of annual precipitation are included in this category. These regions lie adjacent to the regions of heavy precipitation, eastern coastal regions of subtropical zone and east coastal region of the warm temperate zone are included in this category. Regions of less precipitation. This category includes regions which receive precipitation 50 to 100 centimeter. These regions lie in the interior parts of tropical zone and eastern interior parts of temperate zone. Regions of scanty precipitation. The areas lying in the rain shadow, that is leeward side of the mountain ranges, the interior parts of continents, the western margins of continents along the tropics and high latitudes receive precipitation less than 50 centimeters. These regions include tropical, temperate and cold deserts of the world. Look at this map which is depicting the distribution of mean precipitation in the world. Seasonal variations. The regional variation in the distribution of precipitation in different parts of the world are based on average annual precipitation, which does not give us any correct picture of the nature of precipitation, especially of those regions where seasonal fluctuations in the amount of precipitation are very common. For example, arid, semi-arid or subhumid regions. Therefore, it is important to study seasonal variations of precipitation in the world. The facts related to this are that the equatorial region and the western parts of the temperate land receive precipitation throughout the year. The former receive convectional type of the rain, while the latter gets cyclonic cum orographic type through westerlies. About 2% of land areas of the world receive precipitation only in winter. These include Mediterranean regions of the world and Coromandel coast of India. Due to the seasonal shift in pressure and planetary wind systems, these regions do not get precipitation in summer as they come under subtropical high pressure belts and trade winds which become dry while reaching to the western margins of the continent. The remaining parts of the world receive precipitation only in summer. It makes us clear that most of the world experiences marked seasonal variation in precipitation. Seasonal distribution of precipitation provides us idea to judge its effectiveness. For example, the scanty precipitation during short growing season in high latitudes is more effective than that of heavy precipitation in lower latitudes. Likewise, precipitation in the form of dew, fog and mist in some parts like central India and Kalahari Desert has an appreciable effect on standing crops and natural vegetation. Now, what are the factors affecting rainfall distribution? Moisture supply to the atmosphere is the main factor in determining the amount of rainfall in any region. Equatorial and rest of the tropical regions have highest evaporation and hence highest supply of moisture. Coastal areas have more moisture than interior parts of continents. Frigid regions have very low evaporation, hence very scanty precipitation. Wind direction in the belts of trades and westerly winds is very important. Winds blowing from sea to land cause rainfall. Land-bearing winds are dry. Winds blowing from higher to lower latitudes will get heated and give no rain, while those blowing from lower to higher latitudes will get cooled and cause rainfall. Subtropical deserts have very little rainfall because they have offshore winds. Ocean currents. Warm ocean currents are associated with warm, moist winds which cause rainfall. Cold currents have cold, dry winds and hence no rainfall. Presence of mountain across the direction of wind causes more rainfall on the windward side and creates a rain shadow on the leeward side. Pressure belts are closely related with the wind direction and rainfall. Areas of low pressure attract rain-bearing winds, while areas of high pressure do not. Let's sum up. Water vapor is highly variable. It is an important component of atmosphere. It is responsible for global heat balance, atmospheric phenomena, and sustaining plant and animal life on our planet. The water vapor present in the atmosphere is called humidity, which is expressed as absolute humidity and relative humidity. Of these, relative humidity is most reliable measure. Water vapor enters into atmosphere through a process called evaporation. Temperature of the air controls the amount of moisture it can hold at a given volume. The air which holds the moisture to its full capacity is called saturated air, and the temperature at which it reaches saturation point is termed as dew point. Condensation is a process of changing of water vapor into liquid or solid state. It happens when temperature of air falls below the dew point. Condensation occurs near the ground as dew, mist or fog at higher levels of clouds. Falling down of atmospheric moisture is called precipitation, which occurs due to continuous condensation. Drizzle, rainfall, snowfall, sleet, hail are the various forms of precipitation. The rainfall occurs in three different ways: convectional, orographic, and cyclonic. The distribution of precipitation in the world shows marked regional and seasonal variation. Some regions receive very heavy rainfall while others scanty precipitation. Some regions receive precipitation throughout the year while others only in the winter or summer. Several factors affect the rainfall distribution. I hope today's lesson would be helpful to all of you. Thank you.